Okay, hi everybody. So in this video here, we're going to take a look at this little inequation here. X plus 3 multiplied by x minus 5 is less than 0. And there are a couple of ways that we can do this here, and I'm going to show you a couple. Okay. First of all, what we've got here is we've got two linear functions multiplied together, and their product, what I'm interested in is where that product is less than 0. So what I'm going to do is I'm going to break these things up. I'm going to look at the two lines separately. So I'm going to look at the line y equals x plus 3, and then I'm going to look at the line y equals x minus 5. Okay, I'm going to graph them together here. So y equals x plus 3 is going to be a line that's got a y-intercept here of 3. It's got a slope of 1. And then I'll do this in red here. X minus 5 is going to be a line that has a y-intercept of negative 5 and a slope of 1. Now, that means, and it shouldn't take you too much to figure out, that this is going to have an x-intercept of 5, and over here, this one's going to have an x-intercept of negative 3. Now, when you multiply these two y coordinates together, because that's, x plus 3 is giving me a y coordinate, x plus minus 5 is giving me a y coordinate. I'm interested in where that product is less than 0 when I multiply these two lines together. That is going to be in the area, okay, where the y coordinates of these lines have opposite signs. So I'm going to do this right here. Actually, let's change that to a different color here. Let's change that to green. So over here, when x is less than negative 3, when we're over in this interval here, both of the lines are less than 0. Both of the y coordinates are down here, okay? When I look at that interval where the x coordinates are bigger than positive 5, both of the y coordinates up here, both of the lines are in quadrant 1. To the left of negative 3, they're both in quadrant 3. But it's the zone in between, okay, where that line x plus 3, these y coordinates are positive, and down here, these y coordinates are negative. So when you multiply those together, that's when you're going to get a value that's less than 0. So my answer here is going to be when x is in between negative 3 and 5. And I might write this in interval notation like this, okay, where I'm using the soft brackets because I'm not including the endpoints. Now, another way that you might look at this is to see that shape that we're building there, that x plus 3, x minus 5 less than 0, is to take a look at that and interpret that as a parabola that opens up. And it's just written in factored form. I know that it's going to open up because if I look at here, the leading coefficient is going to be positive. I know it's going to have an x-intercept of negative 3 here and one of positive 5 here. I don't even really need to know where the vertex is. It's going to open up. And so then the question becomes, where is that parabola less than 0? Where is the y-coordinate of the parabola, points in the parabola less than 0? When is it in quadrants 3 and 4? And just like I did previously, negative 3 is when it crosses that axis, so it changes quadrants. Positive 5 is where it crosses. Where is the function in either quadrant 3 or 4? That's where the y-coordinates are less than 0. Well, right here, between negative 3 and 5, and I could write that again in interval notation like that. And I think it's easier to look at it this way, to look at my parabola, identify the x-intercepts, and then just identify whether the interval that I'm looking for is in between those two x-intercepts or on the outside of those two x-intercepts, because that's typically how it's going to work with a parabola.